Good afternoon and welcome to NASA's Johnson Space Center for today's mission status as well as the mission management team briefing for the STS-132 flight. Today's activities on board the International Space Station and Space Shuttle Atlantis featured the first of 3 planned spacewalks for the mission. So to give us a briefing about the activities, we have the lead space station flight director, Emily Nelson, as well as the lead spacewalk officer, Lisa Shore, and LeRoy Cain to join us from the mission management team as the chairman and deputy shuttle program manager. We'll open up with comments as usual and then take questions here at the Johnson Space Center and on the phone. Emily?
Thanks. Today, flight day 4, EVA-1 was of course the central piece of work that we did today. The crew did a fantastic job, ran into a couple of snags along the way. The ground teams also had some minor glitches in our systems to work through, and I think we got through all of those and had a highly successful day. At a high level, we completed the physical installation and connection of the spare SGANT antenna. That's going to be our backup KU system once it's fully activated. We also completed the installation of our EOTP and several of the get-ahead tasks associated with the smaller power-related pieces of that device, which was attached to our SPDM, our Dexter manipulator that attaches to our robotic arm. Inside the station, the station crew was also very busy today. Our Russian crewmates were working on some preparations for MRM-1 installation tomorrow, as well as fixing some of our oxygen masks that are on reserve for emergency cases that we found some problems with a little while ago. Tracy was busy working the robotic arm all day with Piers, and TJ was instrumental to getting the crew out the door and back in again this evening. So, and Soichi was working heavily with mid-deck transfer all day long, making sure that we get all of our new cargo on board station. So it was a busy day for everyone. EVA ran a little bit long as we worked through some of the issues that we found, and Lisa will talk through some of those in more detail. But overall, it was a really very successful day, and we're set up to end the day on time so that we can get into MRM-1 installation tomorrow, which is, of course, one of our central mission objectives for the flight. Lisa?
Thanks, Emily. Just like to say, for the EVA, it was pretty much a raging success. We met every one of our major objectives. These EVAs were really hard to, or not, I want to say hard, but they were a challenge to train because we could not complete them end-to-end really in either our VR lab or in the NBL. So until we actually performed them, weren't sure how the timing was going to come out. And the crew just did a fantastic job. They managed to get out the door about 20 minutes early today. We started out to go out to the pallet. We had to pick up our foot restraints, set that up. That all went flawless. The crew was able to release the boom from the pallet with no issues. Garrett got to take his big ride with the boom over there to the Z1. Again, no issues at all. Steve performed all of his cleanup tasks, got over to the Z1 with no issues. We did run into a small hang-up once we went to plant the boom onto the Z1. The bolts that installed the boom to that segment of the truss, apparently when they'd been originally backed out years ago, the torque used to do that was a little bit higher, so we did have to bump up the torque on our power tool just a little bit to get those bolts to move. Once we did, no issues. Boom is securely installed onto the Z1 truss up there. We anticipated some problems when Garrett went back to retrieve the dish. We did have a power glitch that shut down our arm operations for a short period of time, which put us down a little bit on our timeline at that point. But again, at that point, wasn't a big problem because we had gotten a little bit ahead because the crew was doing so well. And then once we were able to pick up operations again, Garrett retrieved that dish, no problems whatsoever. He and Piers worked together very well to handle the clearance issues, to get the dish out. Garrett did his big flight back over to the Z1, and Steve had been able to get all of the power connections complete by the time Garrett showed up, so he was up there waiting at the top of the boom when Garrett arrived with the dish. They worked together really well again to GCA the dish down onto the boom. Another tricky operation, but made it look easy. And then we ran into one of our bigger difficulties on the EVA when we went to drive the 4 bolts that hold the dish to the boom together. The crew noticed that there was still a little bit of a gap between the 2 pieces of hardware. We ended up eventually then just upping the torque on those bolts. It was noticeably more stable once we did that, but we were still a little bit uncomfortable as far as why we're even seeing a gap. So in order to ensure that we were in the best posture possible for going forward and that we could resolve any issues at a later time, perhaps even after STS-132 undocks, the decision was made to put a cloth tether around the base of that dish, and that would ensure that no matter what, we're good for undock and any other loads that we might expect that we would see on orbit. The crew then ran into a little difficulties. We have 2 electrical connectors that connect the dish to the boom. One of them went on with no issue. The second one, it seemed we were just having problems compressing the soft dock, what we call the soft dock that holds the connectors together before we actually throw the final bail. They had problems with that. The crew mentioned during the EVA that thought it might have been thermal. It's hard to say with those connectors. They can be a little bit finicky, but eventually, through some diligence and hard work, they were able to get that connector mated. We were in a good posture even if we had not been able to get that connector to leave the boom. We would have been able to provide heater power to that hardware. So even in that case, we would have been in a good situation for leaving future work for the stage, but we ended up not having to do that. We did not remove the gimbal locks from the S-Gant as we had hoped we might do. The reason for that was there were some still open questions at that point of whether or not that was a good configuration with the question of the small gap between the boom and the dish. Those gimbal locks are still in place at this time, and we will address on a future EVA during this mission or possibly a stage when those gimbal locks will come off, and those are just locks that keep the antenna from rotating when it's commanded. After that, we had already sent Garrett back to go retrieve the platform that was installed onto the Dexter. No problems whatsoever doing that. Steve was able to meet him over there in a reasonable amount of time. They ran into one small issue with one of the 4 fasteners that holds that system together. Again, just a little bump in the torque took care of that problem. That platform is now installed and operational, and Garrett was even able to get all of the accessory tasks, as Emily mentioned, installed. So now we have power to any hardware items that we might put on that platform, and we can also rotate it if needed, depending on which piece of hardware we would want to put on it. And also, big benefit to this EVA, Steve was able to make his way over to the pallet and break torque on all of 6 of our batteries, which puts us in a best posture we could be in going into EVA 2 and gives us a very good chance of meeting or exceeding our expectations for that EVA. So that was basically it. We did do an oxygen recharge on Steve just as a precaution during the EVA. But in no time were we near any of our consumables red lines. So overall, I just have to say a fantastic EVA.
Okay, thank you, Kylie. Well, good afternoon. It's really good to be back here with you again today after another outstanding day of activities on orbit. The team, Lisa's team and Emily's entire team have just done an outstanding job with the spacewalk work today. As you know, this mission has 3 very challenging, very full spacewalk days, and today was the first of those. So I thought the team just did an outstanding job pulling together across the entire shuttle and station combined integrated team. So we couldn't be more pleased with how the mission is going so far. We've had a few glitches here and there, but they're not significant in the grand scheme of the kinds of things we're trying to accomplish on this docked mission. So as far as the shuttle is concerned, Atlantis continues to perform exceptional. We don't have any new issues or problems from when I was last here to speak with you. We did talk about a couple of items at the mission management team today, mostly in the way of status. As you know, we have some work ongoing in terms of trying to evaluate and develop a task so that we can go get this ITVC, our inspection sensor unit cable untangled and remove that snag. And we think that's an extremely simple, relatively simple EVA task. And today we got a status of that. Tomorrow, I think, if not in the morning at the station mission management team, certainly by the afternoon in the mission management team, we will have a discussion about that EVA task and whether or not we think we can add that as early as EVA 2 to occur on Wednesday. So the team's doing a lot of good work where that is concerned, and we feel pretty good and reasonably confident now that we'll probably have a task that we can accomplish that will present very little, if any, interference really to the planned EVA tasks, beginning with EVA 2. And then the possibility of downloading and do it in EVA 3 if we're not able to do it in EVA 2. So we got a status of that work today. We'll get a better overall picture of that tomorrow in the mission management team. The other item that we talked about was, as you know, we have our team is evaluating and assessing all of our inspection data that we have brought to the ground so far. So far we have no requirements for any focused inspection. We do have some areas that we have not had enough imagery yet to assess, or that we have not completed the assessment of the imagery that we have. So we have some work yet to do as we expected. And so that effort is ongoing and proceeding nicely. We did talk about the possibility of adding some more inspection surveys tomorrow to the timeline tomorrow, and that turns out we decided that was not a good option. We are, as you know, primarily focused on the MRM-1 work tomorrow, and that's a new task. It has undoubtedly some challenges and potentially some unknowns, albeit it's been very well integrated and very well trained and understood. It'll be a new operation for us as an integrated team, and that combined with we still have some data coming in, and so we still have some time to assess whether or not we need any more inspection data. And so as of now, we're proceeding forward. We're still evaluating and assessing. The damage assessment team is continuing on with their normal process of evaluating all of the data. And we'll have more of that to talk about in the next couple of days. And so we just talked about that today in the way of a status and made a decision to not try to do anything tomorrow in the way of any additional inspection. So the team continues to perform at a very high level. The crew on board is doing exceptionally well. They are, for only the 4th day in orbit, the 2nd day docked, just really on top of their game and doing a great job for us. So be happy to take any questions you might have.
Thank you. We'll go ahead and start down here.
Hi, Philip Sloss with NASAspaceflight.com. Could you go over the computer switchover that occurred during the EVA? Is there a known cause for that, and what was lost in that during that period that had to be recovered?
Certainly, we haven't fully fleshed out the root cause of the problem at this point, but the preliminary indications that our teams will be looking at in more detail overnight are that some of the connectors that Steve was mating out on the Z1 truss as a part of providing survival power to the SCANT, the space-to-ground antenna system that was installed today, the caps that were in place on those connectors while they were waiting for the connectors from the new antenna system had what we call a terminator inside that finished an electrical connection inside that provided continuity through that bus. When a cap was removed, what we suspect is that broke the continuity in one of our data buses that confused our, for lack of a more technical term, our CNC, our command and control computer, the top level computer, such that it suspected a failure, and in case the failure is with that computer, it goes offline and allows its backup to come up. All of the critical functions that that computer provides are handed over immediately to the backup machine. So we maintained communication via S-band. We maintained the arm saved itself because of that transition of its controller. But all of our other functions within the machine were maintained, handed over from one to the next. Now, KU band, which is video, which is required for video and data transfer, is not considered a critical asset, so that needed to be reconfigured after the transition. The camera system itself needs some reconfiguration after a transition such as that, so that we can basically reset the way that the cameras are routed from the various data buses within the vehicle. So we had to take some time rerouting that, and that's really what took the most amount of time. The arm itself, it was safed, but it took just a few commands to get it back and ready again. The longest period of time was getting the video system set back up so that Piers and Tracy would have all the views they required for all the very tight clearances and the various robotic ops they were doing today. Trying to think if there was anything else. There are a few other cats and dogs that it just takes us 20 minutes or so to clean up from that kind of a transition, but all the critical stuff hands over automatically.
Bill Harwood, CBS. I got a couple, if I could. For LeRoy, if you get the cable snag fixed either on EVA 2 or 3, I assume you would do late inspection the normal way with that. Would you use that system again for any additional inspections you might need? I'm unclear where you stand on SRMS ops, or if you even know if you need any more inspections from what you said.
Okay, yeah, we don't know because we're still evaluating all the data that we have. There is a possibility that we'll decide that we're going to get all the data that we need with late inspection, and that there really is not that much to be gained by trying to get any more survey inspection data while we're docked. So that's really the question at hand is we're going to look at all these areas, all of the areas we've already looked at on the RCC, for example, in addition to some of the areas where we didn't get the kind of coverage that we'd like to have because of the challenge that we had on Flight Day 2. We're going to look at all of those areas for sure, if not before, in late inspection. So the question is, are there any of those areas that we feel like we want to or we need to look at while we're still docked? And we've got a little bit more time to evaluate that. And what I asked the team today to do was to put together those options for us and bring them back in so we can talk about it in the next couple, 3 days. And so we would do something not earlier than Flight Day 7 at this point if we're going to do any additional surveys or any kind of inspection while we're docked.
And 2 more from me. For Lisa, the astronauts made it sound like they were kind of surprised about putting the gimbal locks back in. Like it sounded, and I may just misinterpreted their tone of voice. It sounded like they didn't think that was necessary. I'm just wondering, is that a case where you're just being extra conservative because you had an unknown config with that gap in there, or was there some other issue at play?
No, you're exactly right. We were being extra conservative. We had initially given them the go to release the gimbal locks, and then after some quick conversations with our structures folks, determined that until we could do further analysis that that wasn't possibly the best posture to put ourselves in, and to ensure that we weren't going to create more work later in the EVA if they had discussed it more and then decided that they needed those gimbal locks. The best thing to do was just to reinstall them and deal with it later.
What I was trying to understand is what was the concern? I mean, with that kind of play, and it sounded like it was still pretty tight. I mean, what sort of forces were you thinking could possibly act on it that would, make it get out of where you had it? I just didn't understand the threat.
I think really the concern there is that it was in a config that was unexpected and therefore unanalyzed. And so we need to take the time to go and make sure that the configuration is acceptable for the various loads the vehicle sees, whether that be a reboost or docking or undocking. there are a number of different loads cases that would have to be evaluated, and it's simply that it didn't go exactly as expected, and therefore it's considered unanalyzed at this time.
And last one for me. Is there a defined Dexter task on the horizon, whether a demonstration or an actual R&R?
There is. We've been working for a while on a task that will allow for ground control of Dexter to exchange out a power box, basically a kind of a switch box outside on the truss. And it's been simply a matter of, for a first op like that, especially an op controlled from the ground, we're checking all the boxes and making sure that we're fully prepared for that. But we are planning to do, I don't know the current plan for when that'll be executed, but that is on the horizon.
Mark Carreau for Aviation Week, and I had a couple questions. One regarding the antenna. Is there any urgency to take it out of the configuration that you have it in now? I mean, could you address this in a month or so if you needed?
The only urgency we have at this time is that the gimbal locks themselves, we have some analysis that indicates that when we get to a high solar beta angle, those are going to have some thermal effects that will negatively impact their function, that could negatively impact the hardware. So we're going to have to take a closer look at that to determine whether we really need to remove those gimbal locks during this mission in order to prevent a timer basically from starting and requiring an EVA in the stage, or if we can better understand what we expect those signatures to be and ensure that we'd be okay until either the staged EVA we have scheduled for this summer or potentially the next shuttle flight. Other than that, everything is in a safe config and a good config. Obviously, we can't use the antenna until the gimbal locks are removed, but there's no other safety implications.
Thanks. Thank you very much. I had a question too about the computers. Did you go back to the primary rather than the backup CNC computer? Is there any need to do that? I guess it's command and control computer just sounds like a big deal to me, and it just seemed very inconvenient when it tripped today. It also sounds like you've got a good theory, but I just wonder how much troubleshooting you need to do to sort of nail that down.
We have 3 identical computers. I will tell you the one that we had as prime today is not our favorite. So on the one hand, I'm perfectly happy to be on number 2, which is what we're on now. We were on number 3. Number 3 is the one that went down. Although they are all, from a software perspective, they're all identical. From a hardware perspective, they all have nuances of their own. We did not invest time while the EVA was ongoing to work on psyching out the problem anymore. We haven't done any, as we did some dumps today, but I don't think we did any dumps to try to psych out the problem from that computer today. Overnight, we'll start looking into what information we can get from the computer itself, but with the backup having come up to prime and operating perfectly well, the bus that we saw a problem on was also working perfectly well, so we had no concerns with that bus, although we did keep that bus inhibited in such a way that it couldn't cause another transition. And our third CNC, the CNC number 1, came into a backup mode such that we have double fault tolerance in that system because command and control is such an important function. So within 30 minutes of the failure, we had a fully functional backup again, so that if we saw another failure, we could go to that third command and control computer. I wish I could say that we didn't have any experience with CNC transitions, but not only do we train it quite a bit such that our team was able to respond to it pretty readily, most of us have experience with seeing a CNC transition at some point or another for some reason or another, sometimes not always hardware or software failures. And so it is a big deal, but we were in a good config, and we'll work it out over the next couple of days. I'm not in a stressed situation not having that third computer tonight.
Hi, Robert Perlman with collectspace.com. Sort of following up on that, just to get an idea of I guess, what-ifs with the CNC. If the transition had occurred during an active robotic arm operation, such as Garrett's big ride, what would have been the what would have been the procedures at that point? Would you have would it have been like someone getting stuck at the top of a Ferris wheel, just waiting it out, or would there be a time when he would have to egress the arm and come down?
Well, and basically, there weren't any points today where a CNC failure would have been convenient. The arm safes itself. Once the new MDM comes up, the new computer comes up, we're able to proceed. And so only if all three computers were to come up and fail would you be in a case where you've got to have Garrett take an action to get off the top of this arm that's stretched out and giving him this wild ride. So essentially today we were in the process of moving Garrett when the CNC failed. The arm safed itself, it comes to a stop, and that's to ensure that it's not running without control. We fix the problem, tell Piers, okay, you're ready to go, and he picks back up with the operation. It's only if we lost all three that we'd be in trouble.
And then just looking forward to tomorrow, because LeRoy mentioned the challenges that are the known challenges with MRM berthing. Can you just run through what some of those are and maybe what some of the prepared responses to those challenges might be? Thanks.
Most of the challenges that we have tried to anticipate are associated with the newness of the task, the fact that we've never done a module installation of a Russian module using one of our Canadian arms. And in this case, especially the fact that the active side of the docking mechanism, so the pieces that are actually physically powered and going to move to mate the interface and draw the two interfaces together, are on the MRM1 side of the vehicle. Normally for US dockings or US module installations, you have the mechanisms are on the side of the interface where you have crew members. In case something goes wrong and you need to change something out, you can gain access, you can try to fix it, and then try again. In this case, we've got commands and data going through the arm, power going through the arm, and a module that's fully activated via arm power and control that we're going to bring in for docking. So ensuring that the communication path from the laptop that Piers will be using to control the docking system and to control MRM1 itself. And this is a laptop that is going to be located in the cupola where Garrett and Piers will be working together on this operation, connected via our Ethernet system back to the Russian segment, and then connected via our 1553 system from the Russian segment back to the US segment, back to the arm itself, out to the end of the arm through the grapple fixture into the module. And that's a long path. Now what we've done to mitigate any potential concerns with that is we've tested it a great deal. We've used all of our best simulations, all of our most flight-like units here on the ground. Obviously we don't have all that hardware on the ground, but we have similar devices on the ground, the same computers on the ground, and we've modeled all of those same distances, all those same wire paths to ensure that that link is as good as it can be. Tested the latency in those data lines to ensure that we have a good safe system, because if anything happens to the arm, the module will be triggered to stop so that it'll quit moving so that we don't risk any damage to the arm. So I would say that newness and the fact that we've not done a task like that before triggered us to do a great deal of testing. All that testing was successfully accomplished. And so we have good expectations that all of that will go nominally. There are also some, all of the normal things that you look at in a mechanical system, any place where any one thing could fail, what do you need to do? The docking system itself is a truly elegant system from an engineer's perspective. It's worked hundreds of times on progresses in Soyuz, both to Mir and to ISS. So we did go through, and because from a shuttle mission perspective, this was a first for this particular interface, although our ISS teams have a great deal of experience with this particular interface. We spent a lot of time talking through what are we going to do if individual things fail, and we have backup plans for all of those. In most cases, there's redundancy built into the system, so we don't have to do anything. I think that's most of the challenges that we can look at tomorrow, although Murphy's Law, we've prepared for it as much as we know how, so it'll be something else that happens.
Any other questions here? Go
Mark Carreau for Aviation Week. I wanted to follow up that question, and you may have answered. If so, I'm sorry, but is there any kind of a clock on that operation where you have a sort of deadline you have to work within, and if there is, what's the consequence?
Absolutely. The only clock that we'll be working from tomorrow is there is a period of time in between. We'll have to shut power off to the module while it's in the payload bay because it is not powered while it's on SRMS, while it's on the shuttle arm. So after the SRMS grapples the module, we'll shut the module down and take it out of the bay. And when the SSRMS, the space station arm, comes to grapple it, and then we have power available again, we'll repower the module at that time. We have a clock limiting the amount of time that we can perform that operation from power down to power back up. Once we get powered again on the station arm, we're in a good config. And that time period is based on not so much the module itself, but we've got a number of important pieces of hardware attached to the exterior of the module that are all going to be installed on the MLM module that'll be flown on a Russian rocket to the space station at a later date. Those pieces of hardware have survival heaters associated with them, and it's those that are driving the need to get activated again. We've got on the order of 5 to 10 hours, though, so it's nothing it's not going to be a nail biter by any stretch of the imagination.
We'll take some questions on the line then. First up is Mark Kirkman, please.
Hi, Mark Kirkman, Interspace News. If I may, I've got a multi-part question for Emily. In the briefings before, you talked to us about how MRM basically needed to be attached not too slow but not too hard. And I was wondering if you had good numbers for us on what I guess Garrett calls ramming speed. If you can give us either actual rates, or if not, maybe just draw a comparison of how much faster this is compared to normal arm operations. And the second part of my question is I'm a little ignorant on how the space station arm operates, and I was wondering, does Garrett have the ability to directly control the rate of the arm through a hand controller, or is this a rate that you program into it and it does it automatically? Thank you.
Certainly. I happen to bring the numbers for the rates. So for example, MRM-1's installation is going to happen at 0.06 feet per second. By comparison, the shuttle docking a few days ago, Atlantis' docking, occurred at approximately 0.1 foot per second. So that's 0.1 versus 0.06. And a Russian visiting vehicle, which is where this docking system is normally utilized, comes in at something like 0.3 to 0.6 feet per second. So we're going sometime up to a tenth slower. I guess we're going 10 times as slow as a Russian vehicle normally would that uses this interface. In terms of whether Garrett has control, what kind of control Garrett has of the arm, we have max speeds. So basically, we have a speed limit built into the arm so that we don't allow him to take it maybe as fast as we'd like for him to take it, or as fast as he'd like to take it. But we have either, when we're doing programmed motion, we have course rates and what we call vern rates. So we have a slow rate and a fast rate, and those are pre-programmed, and the arm will ramp up to that speed and go that speed and then ramp back down when it's finished. When we're doing manual control, which is what we'll be doing in this case, Garrett does in fact have control over the speeds himself, but there is a limiting factor within the software such that he can push on it as hard as he wants and it's still only going to go at 0.06 feet per second.
All right, that's all I had. Thank you very much for your time.
Okay, next on the line, Marcia Dunn.
Yes, hi. For Emily Nelson. Do you have any idea how long it's going to take to analyze the antenna situation? Days, if not weeks. Do you have any idea at this point?
Well, I would say that we have to have at least a preliminary answer within days in case they're wanting us to do something about it before Atlantis undocks. My hope is it'll be on the order of a day or two, but I really don't have any idea at this time since the engineers started working on it as soon as I left the control center, so I haven't had a chance to ask.
And for LeRoy, do you have any sort of debris update, anything new that might have been seen in any of the launch day video, or total number of debris incidents that came off the tank?
No, I don't, Marcia. I don't have any new numbers in terms of total numbers of debris that we've seen. We are about where I expect us to be in that part of the process, and the imagery team did give us an update on where they are with respect to their expectation on Flight Day 4, and they're right pretty much where they plan to be on these missions. So in a couple of days, we'll have some more information, and we'll have an opportunity to see some videos, and we'll be able to talk a little bit more about some of that data. So I don't have any new number to give you per se.
Thank you for me.
Okay, Todd Halverson, please go ahead with your question.
Thanks. Todd Halverson of Florida today. I actually have two. The first for LeRoy. Given the fact that you're not going to have a focus inspection tomorrow, would there be any changes to the timeline in regard to what you would have been doing on orbits 62 and 63 during that time? Thanks.
There will be some activities in that time frame. The team today, when we asked that question, said we have sort of a shopping list of things that they wanted to try to accomplish in that white space where we would have done a focus inspection if it should have been deemed necessary. So I don't have the exact tasks to detail them for you, but there were a handful of items that they had planned on being able to do and accomplish in the event that we didn't need a focused inspection. So once we get the updated timeline, Todd, we can give that information to the public affairs team, and they can make sure to get it to you.
Thanks very much. If you could just confirm for me whether the MRM timeline will remain the same as advertised right now, that would help. And then I have one for whomever wants to field it. I'm just wondering how tricky it might be to actually thread the MRM up through the stack to Zarya tomorrow.
I think I can take both of those. The MRM1 timeline is roughly the same, although we did get ahead and grappled MRM1 before the crew finished up operations today. So we're ahead by that first half-hour activity, so we may get maybe a half an hour earlier start in the morning, in the crew morning. In terms of threading MRM1 into the installation location, it actually is a pretty free trajectory from the shuttle payload bay kind of down and around up to the nadir port on the Zarya module. And so with the comment from Garrett and Piers when they saw what those views were going to look like out of the cupola windows, their comment was basically that with those views they don't need camera angles for most of that trajectory because they can see the entire arm and they can see the module itself. So once we get close, there'll obviously be far more attention paid to the alignment, but for the automated portion of the trajectory, which is the largest sweep from the handoff from the shuttle arm all the way over to pretty close to the Zarya module, that's a pretty free motion without a lot of hardware around it.
Thanks. That's it from me.
Okay. Next on the line is Clara Moskowitz.
Yes, hi, Clara Moskowitz with Space.com, and this is a question for Lisa, I think. I'm wondering if you do decide to complete the antenna installation during one of the two remaining EVAs on this flight, do you have any idea at this point of how much of an impact it would have on that EVA schedule? Basically, does it seem like there's a lot of work left to do, or would it be a minor addition?
Basically, right now, when we talk about completing the SCANT task, all that really would need to be done possibly is remove those gimbal locks, and depending on what the teams come back as far as the attachment of the antenna to the boom, maybe retorquing those bolts. So we're probably looking in the neighborhood of 30 to 45 minutes worth of work for a single crew member up on top of the Z1, and we're just going to have to see how EVA 2 and 3 go with our primary objectives, and then, as Emily said, you know, wait and hear what the analysis comes back on the gimbal locks as to whether or not we'll actually go do that.
Okay. Did you have another question, Claire?
No, I'm all set.
Okay. And finally is Irene Klotz.
Thanks very much. Irene Klops with Reuters. I had a question about the CNC transition. I was wondering first if it has ever happened during an EVA before.
Irene, that question was kind of hard to understand. Maybe you're too close to the microphone on your phone.
Is that?
That's too low, I think.
Can you hear me okay now?
That is better.
Thanks. On the CNC transition, has that ever happened during an EVA before?
Oh, goodness. I can't say definitively one way or the other, to be honest.
And the other question I had is, I thought I heard one of the astronauts say that there was a loss of EMU data during that transition. Was that the case?
There was. It was just the in the transition of, like Emily said, reestablishing of the, I guess, our standard config. Just in the process of reestablishing that, we did lose suit data. So the data is actually coming from the EMUs down to the ground for a short period of time. But during that entire period, the crew can monitor their own suit data.
Thank you. And what was the total amount of time that it took for the computer to reset?
In terms of the critical functionality, so not including the video reconfigs that we had to do manually, I would say it's on the order of 2 to 5 minutes at most to go from the primary computer to the backup and have all of that critical functionality handed over. I think today it was more like 2 minutes.
And then how much longer to have video so that the arm could be moved again? I clocked it at somewhere around 10 minutes, but I just wanted to...
Yeah, I want to say it was about 15 minutes, 10 to 15 minutes by the time we got all of the configuration set back up for the video routing to support Tracy and Piers's continuation of the arm ops.
Okay, thanks very much.
Okay, do we have any follow-ups here?
Just one quick one for Emily. Just to be clear on MRM1, I think I know the answer to this, but there is no hardware that can be messed with if something doesn't go right. This is all software driven, and it'll either work or it won't. And the only fallback position is to put it back in the bay. There's no way to leave it anywhere else if you run into a problem.
Fundamentally, yes. There are some hardware failures in the MRM1 itself that the backup for those failures is in the Zarya half of the interface, which is why we're doing MRM1 install in the morning, because the Zarya half of the interface is only commanded via the Russian ground sites, which we only have in the morning, in the crew morning period. So we were careful to schedule that activity to leave ourselves plenty of Russian ground sites after the nominal completion of installation in case, for example, if the probe works fine and we draw the two interfaces together, but the hooks are for some reason not working on the MRM side of the interface, then our Moscow team will send commands to the Zarya side of the interface and drive the hooks from that side, which accomplish the same goal. They're exactly the same hardware physically located in the same spot. So fundamentally, yes, there's nothing that we can do if there are failures in MRM1 in terms of gaining access to hardware, except for that one where the backup hardware is actually located on the FGB side, the Zarya side.
Thanks.
Any other follow-ups here? Seeing none, we'll go ahead and send NASA television back to Mission Control for an update of the activities in space. And as always, you can follow along on the internet at www.nasa.gov/shuttle. Thank you.